Hi, it's Warren Whitlock here with the Emerging Technologies podcast. And today, let's talk a little bit about batteries. Energy is going to be important part of everything we do as we move into the abundant future. We'll probably be using more electricity, as much as double in the next 30 years. Where's that going to come from? Is that going to be the electricity we've been getting? Or do we need to get a little bit more picky about the sources of that power? And if we can use sun, solar power, and wind, we'd be getting that in the way we've been getting it, which is only when the wind's blowing or only when the sun is up. Or are there ways to store that and do better? So batteries are an ultra important part of this. And I want to talk to you about some stuff I've learned about batteries that I think is going to make smooth out a whole lot of this, and in some cases maybe make the power that we use a lot better. First of all, to me, a battery is anything that stores the power. In some cases, they're using solar. Actually, I think my house gets this power. It's here in Las Vegas, and a lot of the homes are hooked up to the grid in such a way. It's the grid, so all the power kind of gets mixes together. But we do have coal power, and we do have old ways of doing. We have hydropower from the Hoover Dam that we really don't get much of. That's mostly for California. And but point is, there's this great thing that you see when you drive to California out in the desert, where you see a lot of mirrors pointed at a tower. And I think there's three of them on that one. And you can see what's going on. And it's the solar is not collecting in the converting to electricity. They're aiming all of this with mirrors at these towers. And so I had to investigate, and I found out there's two of them. The other one is in Nevada. It's 50 or 75 miles from us. It is supplying power to the Las Vegas metro area. And so as I discovered, what's happening is the sun hits the mirrors. They're aimed at the tower where there is salt, and the salt is melted, molten salt. And yes, everything melts at a certain temperature. Salt is fairly hot, also retains the heat. And so they put some kind of system to get it up in the tower and then back down. And then the heat coming off of that molten salt causes a boiler to work and generates power. In fact, a lot of the power we get comes from there's something being heated up, and there being some kind of generator that turns, and that makes the power go. Whether or not you're burning coal or using solar power, those work somewhat the same way. So that's one kind of battery. Salt can be a battery. And then of course the other one that I really like is when they find out when their power is plentiful, they pump water up into a reservoir, and then when the power is needed, that water is let out and by gravity falls through the wheels and mechanisms and whatnot, and then generates the power there. Instead of having to have the steam involved, it actually is just completely reusable, just water falling. And then at the bottom, they can pump it back up to the top when there's excess energy, so that, say, with solar power, you would have power at night that way. So those are great. But most of us, the batteries that we know about and use all the time today are primarily lithium ion, which is a battery that comes from a really smart guy. I studied him a little bit, and if you want, go find that guy. It's easy to find. His name is John Goodenough, and I guess he could have had another name, but that one was good enough. Okay, that's the stupid pun. Hopefully, you'll remember his name that way. He won Nobel Prizes for things he made to miniaturize and make for better power and things like that, like work he did back in the 70s. And that gave us lithium ion. And then some other compounds he's worked on. And in the last 20, 30 years, he's working on one. He's 90 something and still in the lab every day working on stuff, other things that they can do like that. EVs, electric vehicles, have been using lithium ion batteries and packing more and more juice into smaller and smaller space. So the batteries we're getting today, the reason why your cell phone charge will last a whole day or 2 days is partially because they've managed to make them bigger. In some cases, I have the biggest phone I can get because it makes it me able to read it. but also it makes for a larger battery, and that battery just lasts better. And all the circuits running off of it, they've optimized to make it work better. So everything works better and better all the time, and that's going to continue on. One of the limitations to that is the supply of lithium, and lithium has to be mined. It comes out, it's very plentiful in various places, and then it has to go through processes that aren't as bad as some of the other mining processes you hear about, but are still more work than and more environmental concern than if you were just able to scoop it up and use it. And so one of the problems was whether or not there was enough. Since I've been studying lithium, the amount of lithium that they've discovered has skyrocketed. It used to be there are several places where the lithium comes from, and now it's every country has lithium mines at this point. So there's a lot of lithium around. That's not the problem. The other problem with lithium ion is those ions. The way that part of it works, in every battery, you have to have an anode and a cathode, or a plus and minus. Plus and minus is what we call them. Anode and cathode is what the technical terms are. So I'm just going to say plus and minus. So you get the lithium on one side, and then whatever else goes with it on the other side. And there's various things, and they keep improving them to make the batteries last longer. And so what happens is ions will move from one side to the other side, and there has to be something in between, usually some sort of a gel, whether or not that's in a battery, that little battery you put in electronic equipment, all the way up to cars. It's the same kind of things. And even when it gets to be batteries that are like size of a container and can store power for the power grid, they still basically have the same sort of process of the charge moves from one side to the other. And as it discharges, it moves back. What happens with lithium is that it goes through that substance, and some of the lithium leaks out, and it's almost like building stagnant the things in caves that hang down from the mineral deposits. You get little things jutting out from the side of the lithium towards the other side. If it ever reaches over the gap, the battery shorts out, and goodbye battery, and maybe a fire. So it's something they've really had a lot of concern of. Although modern batteries now are able to have solid state, where that the space in between the plus and the minus is filled with something that isn't going to make any difference. And of course, they keep changing the chemistry. And if you can't build up something to charge through because it's not a gel anymore, it'll last longer and work better. Early electric vehicles could only go 100 miles on a charge. Now we're seeing 500 to 1,000 as possible. And to beat what a gas engine needs, if you're getting 300, 400, you're doing really well. Also, the number of times you can charge used to be concerns about, oh, you've got to be careful about how you charge it. If you leave it on the charger, it's going to go bad. Nope. We've got all sorts of circuitry taking care of that now. And in addition to that, we've got more cycles that they can take. So that's why you're able to buy a cell phone with the battery built in, and you will replace the cell phone before you need a new battery. The battery will get worse over time, but not bad enough that you need to get rid of the phone. So lithium ion batteries just keep getting better, and they aren't the only game out there. And I did put up a list of things. There are iron chloride cathodes. There is graphene, the miracle substance, which is one layer thick of carbon. When they stick that with the right compounds, they can be batteries. That graphene does everything. Lithium sulfur still uses lithium, but changes to sulfur. And so whether or not you're building a huge battery to power a neighborhood, or a small battery to go in your hearing aid, they're getting better all the time. These new AirPod Pro 2s I have go a couple of days without me having, I have to stick them in the charger, but the charger doesn't need to be recharged for sometimes a couple of days. So I try to charge it once a day, but it's just always there. And if I was talking here and the battery went down, I could take them out and not hear as well for a minute. And in 10 minutes, sometimes I have the batteries back. Between that and spare headphones and such, They've become very workable. Hearing aids that you can stick in your ear are little tiny thing. Now the battery's the biggest part of that, but they go for a whole day. That's what I like about these is they're so easy to put on and off and carry around in a case that I'm really enjoying them. New technology, hearing tests on my iPhone, not available a month ago, now something I depend on every day. So, what are we going to have in the future? I think more batteries in more places. I think the technology keeps getting better and count on having things like you're able to not have never go off the grid, always have power, and then generate a whole lot of power. I've said since I've lived here in Las Vegas, 20 years now, that why aren't all of the houses covered in solar panels? What a great thing. And I think we talked about solar before. The cost of solar panels is down to 5% of what they were 10, 15 years ago. They keep getting less expensive. The installation is still somewhat of a problem. You've got to build a rack and screw in all the panels on top of a roof. But one of the products that Tesla was making was a solar panel in a roofing tile. I think we're going to see more of that. They're going to perfect whatever that is and make it so that you have solar when you move into the house. And for the next 30 years, that house is generating enough electricity for itself and maybe some extra to power the car or whatever. So I think those are going to become better and better. And we've not even touched the other ways to produce electricity like hydrogen. Once you get hydrogen hooked up to anything, its use just goes everywhere. I've even seen the plans for an electric plane, though again, you got to worry a bit about weight and range on planes. But I have seen an idea and they're working on the company right now. This is not future technology. This is something they're trying to do. Be able to take people from Midtown Manhattan or downtown, lower Manhattan, I believe, at a fixed point and use what looks like a drone to pick with passengers in it to go on a fixed route out to the airport, JFK, and that will take no operators, and the landing places will charge the batteries, and so they've worked out all the details to make it work. Now with existing technology, I believe it's in the funding stage of somebody has to invest in making that happen. But compared to taking a helicopter ride from the roof of a skyscraper in Manhattan out to the airport, it will compete with that, and if not be cheaper. And because of the less labor in flying it, it'll be able to expand and grow and actually bring down the cost of getting people there, eliminate being stuck in the traffic that's on the ground. And so that's even in flying, we've got battery technology getting better at that. Yeah, if you were thinking that the batteries are going to be a block that's going to slow it all down or stop it, not so. Technology coming soon, emerging now and coming into commercial use is just going to make things better and better. We're going to find more lithium or its alternative and make batteries out of all sorts of things. Nice thing about that graphene is we never run out of carbon. I wish we could figure out how to take it out of the air and turn it into the batteries, but probably somebody working on various parts of that. There's no theoretical reason that wouldn't work. And so, talk about carbon free, we're talking about carbon sequestering in a battery. So, who knows? Yes, on the downside, some of these technologies do take some energy and could cause some pollution in how they're mined and put together. But you have to compare what's coming to what we get if we try to build all this on coal and oil. The world is going to grow, it's going to prosper. People don't want to give up their technology. So the West getting rid of their technology or slowing down to let the rest of the world catch up, don't see that happen. I see us coming up with better ways to take care of this, some way to either clean the air or whatever we have to do, make things better. So compare what's coming to what it would be if we just grew by burning more oil or coal. And it's going to be there. In fact, not only that, but why not make oil and coal cleaner? Somebody's working on that, I know. Maybe that'll be a future episode. That's it. That's what I got to say about batteries today. And so this has been the Emerging Technology podcast. Be sure to leave a comment or subscribe and like us. That really helps me get the word out to more people. But always open to your comments. Drop down below wherever you're seeing this. Leave a comment and it'll get to me. I'm Warren Whitlock. That's it.